Hello everyone. Today I will be talking about how we can achieve validated results in different types of data analysis. Particularly I will be talking about chemistry type of problems. So in this talk, first of all I will explain that what different types of items we are going to understand. So initially I will be explaining what is the importance of a chemical measurement, but I will be talking about the importance of a chemical measurement based on different types of common world problems that are actually non-chemical questions. So we can say that I'll be able to answer different non-chemical questions by using different types of chemical measurements that we normally practice in our chemistry lab. Furthermore, I will explain different types of measurements, and particularly I will be talking about few other related terms. These few other related terms, they are also very important for the elucidation of your data, and that data should be without different types of error, and how we can estimate different types of errors, and a proper estimation of different types of error can also be included in the form of analytical budget, and that analytical budget will help you to evaluate your data as a valid analytical measurement. So in this talk, starting from the basic measurements, and we will conclude our talk to the valid analytical measurement data protocol. So first of all, for the importance of measurement, so first we have to identify what are real world problems. So there are different types of world problems, for example related to pollution, for example related to food scarcity, for example related to efficiencies of different types of industrial reactions and production of fuels and energy related issues. So first of all, we have to identify that what sort of real world problems we are able to solve, and for those real world problems we have to decide that what type of chemical measurements, what type of different methods, what type of different equipments, what type of different protocols are actually helpful for answering that question. And at the end we will be able to solve that problem, or we haven't solved that problem but we learned something about that problem. So after deciding or selecting the proper protocol for that real world problem, we will be having a method, and every method has appropriate measurement protocols, and those appropriate measurement protocols are very important to check and to verify whether these methods are validated or not. And after doing different type of appropriate measurements, we are obtaining few results, and I will be explaining that how our result is can be easily interpreted, that has different values, different uncertainty measurements, and there are different appropriate units for these results. And I'll be also talking about that how different errors they are actually accompanying these results. So everything comes under the heading of a proper or validated measurement protocol. So at the end, after achieving different results, interpretation of those results provide us a solution or a kind of indication or a pathway towards a proper solution to that real world problem. So it is quite obvious from this enlisting that there is a clear relationship between the real world problem and different types of proposed measurement. So not only for chemistry, actually for all life sciences, for all chemical or natural sciences, these measurement protocols, they are very important, and they are actually helpful in solving different real common world problems. So to have a proper validated methodology in this regard is highly desirable. So today this is my topic, and I'll be explaining more about these different types of measurements and associated terms and associated errors related to these protocols. So first of all, in chemistry we are actually relying completely on measurements, and measurements, they are of different types. But what are measurements? Actually, they are different types of operations that we are performing, and our purpose to perform those operations is to determine what are the particular values of a specific quantity. So that values can be in the form of length, can be in the form of weight, time, or diameter, circumference. So there are many examples. So in every explanation of any quantity, any object, there are different sets of operations, and these sets of operations are actually called measurements. So before going into deep elucidation of this topic, first I'll introduce few more terminologies that are actually related and very close to this protocol. So the first is what is actually a quantity. So we can say that it is actually an attribute of a phenomena or body or any substance that can be easily distinguished qualitatively, or you can also quantify that. So what does it mean actually? For example, if you want to check the concentration of a particular compound in any solution, for example, I want to see the concentration of sodium chloride in water. So the first step is I have to identify that what substance is there and what is my substance of interest. So that will be a qualitative distinction of that substance. So we can say that that quantity is related to actually that substance. So in this example, I have sodium chloride. So I want to figure out what is the concentration of sodium chloride in water. So the sodium chloride is the substance. So there must be, we are going to measure this quantity. So of course there will be a magnitude of this quantity, and that magnitude will have some value, and that value we are normally using for expressing different types of quantities in our measurements. So the second step, after identifying the particle of interest or substance of interest, we have to give a certain value. So how can we achieve that value? So we have to do different sets of operations. They are called measurements, and by measurements we are getting different types of values. So value, we can say that these are actually some magnitudes of a particular quantity, and normally we are using unit of measurements for expressing these values, and along with unit of measurement there will be a number, and combination of both things, number and a unit of measure, will actually provide you a value that will express a quantity. So measurement is related to quantity, and quantity can be expressed in the form of value. Alright, so in different types of measurements we are facing a lot of errors, and this is part of our researcher life. So first I will explain that what is an error. So for example, if you know a true value for any measurable quantity, then after repeated experiments you are getting some results. If your result that is actually coming from your measurement has some difference with the expected or the true value, so later I will explain that how you can achieve this true value as well. So if there is a difference of your measured results with your true value, then that is actually called the error. So there are different reasons for possible reasons for these type of errors, and for this main difference between your measured results and your true value. So here I have listed three important type of errors that are actually explaining your measurements and how certain your measurements are. So first of all, I'll be talking about some gross type errors. So gross type errors, these are actually mistakes that are you can call them as personal errors, and these are mistakes that can be related to any fault or maybe you skip some step, or you didn't do your arrangements or the proper setup for your experiments, or you are not for example measuring something that has to be measured in a different way. So like that. So these gross errors are actually giving you a very faulty results. I'll explain in coming slides that how these gross error based results are different from true value. Similarly, systematic errors, these are mostly related to your methodology. If there's any problem with your methodology, or if there's any problem with your protocol, or problem with instrument, if you are using any equipment for measurement, or a part of an equipment. So these systematic errors, they are also giving you a total different type of results as you were expecting. So another random errors, these are the reasons for these random errors. They are actually not very visible, but there are a lot of factors you can attribute those factors to these random errors. I'll explain them comprehensively in my coming slides. So while doing measurements, we have to weigh some material. We have to do some sort of calibrations. We have to use some equipments. We have to use some normal glasswares. We have to measure different types of things. We have to do different types of calculation for starting any wet chemistry process or some analytical process. So if there's any mistake, any small mistake really in these processes, in these steps, then those mistakes will lead you to an error, and that error is actually giving you a different result in every time when you are going to repeat that experiment. So that's why it is highly recommended that repetition of experiments and having an average or a mean value is very important, so that you can see that if there's any gross error that is related to your performance, and you can see very easily that these performances, they are actually directly related to a person who is performing these experiments. So you can also assign them as personal errors, and we can easily avoid them by different types of statistical analysis, and we can estimate them. And the important thing is we have to remove them from our data. Otherwise our data will not be repeatable, and it will be with a long range of errors. So during these type of errors, it is very common that you will see some outliers, but you must be aware that the outliers, that turns out to be the only halfway decent result. So it's very important for estimation of your measured data for any quantity. So for talking about systematic error, it's directly related to your method, whether your experimental protocol has some problem, or you are missing something in your experimental protocol that is not suitable for solving that problem, or it is related to your equipment. And in every equipment we are also using different methods and different protocols that we have to follow them. And if there's any difference, or there's any problem, or there's any mismeasurement in any of the step in that protocol, that will lead us to systematic error. And for example, here a colorblind person that is not aware of his disease is always persistently overestimate the end point in a titration. So the problem lies in his vision, that he can't see the proper color. So his end point will be always different. So the extraction of analyte from the sample may be only 90% efficient, or maybe less than that. So it depends that how professional he is. So still you can see that in your protocol there's a big error. So that error is actually because of that protocol, or the wrong method, or some missing of some important steps during that protocol for that particular measurement. So if the results of these kind of errors, if you're not correcting them, then always whenever you will do these type of measurements that have some systematic error, you will always see that your result is actually deviating away from your true value. So for this case, we are actually calibrating our systems, our equipments, our methods, our protocols by different ways, by using different types of reference materials. For example, in electrochemistry, we are measuring current and potentials with respect to our reference electrodes. So these reference materials are very important to check or to calibrate whether our equipments or our methods or our protocols, they are right. So the difference between the average of the measurements that have a systematic error and the value of the reference material is actually give you an estimation that how much error you have in your measured value. So it is very important to remove this type of error to get a result that is close to true value. So there are some errors that doesn't have very clear or visible sources that we can't distinguish them very clearly. So for those type of errors, we have to do repetition of our experiments. So for example, if you are doing a lot of different repetitions of your chemical experiment, you will see a slight difference in your answer. So that slight difference in your answer is actually related to this random error. So it is always advisable to have such control on your reaction conditions and to have a consistent protocol so that you can avoid these type of random errors. So sometimes the result is a bit more than expected and sometimes a bit less. So you can have values on the both sides. So taking the average of these large number of repeated measurements, you can easily have a value that can be statistically correct by using different statistical analysis, and your value should be close to mean value or the true value. So if I'm talking about the factors that are actually affecting these measurements by random errors, so for example, the inability of the analyst to exactly reproduce conditions. So sometimes it happens because every person is in a different mood one day or different mood on the other day. So it's might possible that in one day he was more relaxed and he did experiments in a more professional way, but in the next day his friend was waiting outside, so he has to finish those experiments very quickly. So all of these type of errors, they are actually covering the random errors. So fluctuations in the environment, they are very common for not well maintained labs where there's no temperature maintenance or the pressure maintenance. Then these kind of problems are very common. And arithmetic calculations, so in less professional way, if you are not rounding them equally every time, then you will see these kind of small differences in your measurements, and maybe some sort of brief gust of wind that disturbs your weighing balance or disturbs your weighing powder that flown away by that wind, or maybe because of the shake of the analyst's hand. So here we can see that there are different types of errors, and every error has some cause or some reason. To avoid those errors and to have a consistent result, it's very important to evaluate your experimental protocol before doing experiment and try to have a consistent protocol or consistent validated strategy by which you can achieve a particular result. Alright, so here I'll present one example. So pipetting is a very common experiment, and most of us are using glass pipettes for measuring different materials. So if I have a 10 ml pipette, the manufacturer normally specifies that At 20 degrees centigrade, it is only guaranteed that you are going to measure between 9.98 or 10.02 milliliter if I have filled that pipette properly up to that mark. If I didn't, then that's personal error. But if I am trying to have a filled pipette very close to that mark, so still you can see that according to the specification that are from the manufacturer, that that pipette will give you an error of plus minus 0.02. So this type of error is actually can come under systematic error. So repeated measurements they are actually helping us in this way. When you use a pipette, can you really fill that pipette exactly at the same time? Or I think it's impossible every time, because if you are having 10 experiments and you are trying to fill up to that mark, so sometime you will be lying below 10, and sometime you will be lying above 10. So these type of random errors, they are also part of your measurement. So another important parameter is actually the reaction condition. As I talked before, that the temperatures in our labs and some other external parameters that are affecting our measurement, that will also cause errors. So in this example, we learned that by different types of repeated measurements, or by avoiding some important or big systematic errors, we can have a good result. So there is one new approach for having a validated result, is actually called uncertainty approach. So in this uncertainty approach, what we are doing is we are ensuring different various components that are actually causing different types of errors, and we will see that what is the extent of that unknown value to our measurement. So that extent is actually very important to take into account to understand our own results. That will help us in the better interpretation of our results, and that will give us a sense of confidence, and that will also save our time, so that we will not waste our time on doing those repeated measurements and repeated wrong measurements. So here in this image, it's very clear that we have a true value on the left side, and the systematic error difference with the true value is actually quite large. So if there is any systematic error, that might be related to your method, your protocol, your equipment, your calibration of the equipment, or your faulty instrument, anything, that will give you a long deviation or a big deviation from your true value. So systematic error must be removed from your system, must be removed from your protocol, otherwise your measurements, they are not right. So second type of error, that is random error. You can see here these random errors can be easily distinguished if you have different measurement results after repeated experiments. So normal distribution of results has some difference, then that difference can be attributed to different random errors. We have discussed those random errors in previous slides. Alright, so if you have a gross error particularly related to personal errors type, and where you have a big mistake in your calculations, or some other negligence, not careful weighing of your reactants or precursors, or not careful following a protocol that is devised for any instrument or equipment. So that gross error will give you a complete outlier, and that complete very clear outlier gives you an indication, so there is a big mistake in my measurement. So just the good thing is, go back, check your protocol, and have an idea that where is that mistake. So by this discussion, we are able to distinguish that there are three different types of errors, and how these different types of errors are actually affecting our results. So if we have systematic error, our result will be quite away from true value. If we have gross error, that will be an outlier. And if we have a small difference in our repeated measurement values, that will actually is a random error. So talking about these measurements and errors and the accuracy and the confidence of your results after different repeated measurements. So important terminologies related to this topic are accuracy and precision. So in this image you can see on the left side we have different set of data. These different set of data, they are distributed at various values, and there are very few data that are close to our main target value. So you can say that this set of data has low accuracy because there are more data that are actually not close to our target value. Similarly, in the same set of data, you can see easily that there are different set of data. They are far from each other. So it means that your measurements, they don't have good precision. So low precision, low accuracy data is not good for analytical measurements. So it is always advisable to have high precision and high accurate data. So in this regard, the first important point we should take care in our mind that our answer must be right. So our answer must be close to our true value or expected value. So that true value or the expected value set of data with some acceptable uncertainty is actually good. So trueness without precision is not a desirable state. But if you are close to true but you are not precise, then you have some set of data that are actually close to your true data, but it's not desirable, it's not perfect or ideal way of measurement. So achieving a reasonable answer, we have to have we must have a set of data that should have some accurate measurements, and their precision is also accurate, because these accuracy and precision, they are actually directly dealing with your repeatability of your experiment and reproducibility of your experiments. So both things, they are very important for analytical measurements. Alright, so explaining values, explaining quantities by different measurements, we need some significant figures. So there are different rules, and they are very common in chemistry and for analytical measurements. I'll just try to emphasize on a few points here. So significant figures are actually paying some good impact on our information, on our measurement, and these informations, they are actually very useful. So these significant figures, they are actually helping us to have a more precise result. So there are different ways of counting these significant figures, and we are normally using scientific notations for this purpose. And if you don't have scientific notations and you can't see very easily the significant figures, then it is very easy to write different values by using scientific notations. So here below I have three different examples: the concentration of copper, glucose, and mass of ammonium nitrate in different solutions. So I will, in next slide, I'll show you that how we can convert these values into significant figures. So for the first one, after decimal there are 50 and then 572. We can write this value as a 5.72 to the power minus 6 molar. So here now we can see that there are only three significant figures, and the zeros before those significant figures, they are not significant. So we can easily write them in the form of scientific notations, and these scientific notations are actually giving you a more professional estimation of your writing. Similarly, in the next example, 5 millimolar can be written as 5.0 into 10 raised to power minus 3 molar. And here we have two significant figures. And same case for 5.20 tons of ammonium nitrate that are actually equivalent to 5,200 kilogram. And we can express this value in scientific notation, and that is 5.20 into 10 raised to power 3. And here in this value, we have three significant figures. So by using significant figures, our writings will be more professional, and we can easily estimate are values, and these values or the results that are actually obtained by the interpretation of this data will be more precise. Okay, so at the end of this discussion, I will give you some important points by which you can say that if you are going to measure, so if you are going to do some measurements that are actually answering a common world problem, that my method or my protocol is validated. And what is the important point for that validated analysis? To achieve a validated result. So I have few important points that everyone should take into account to understand whether these protocols, they are validated or not, and you have validated results or not. So first of all, if you before in talking to your before performing any experiment, you have to understand what are the basic needs or the basic requirements of your customer. And your customer can be any industry, your customer can be any particular community, or some hospitals, or some anybody that is actually requiring some analysis from you, or they are actually looking for some problems that are related to their job or their businesses. So first of all, we have to understand what are their basic requirements and what type of results in what dimensions they are actually looking for. So, and then you would be able to easily validate the methods and the equipments that you are going to use to figure out what are the solutions for those problems. And another important, you should rely on your qualified and competent staff, and if you are lacking in that, then it's better to supervise your staff so that you can have a better validated results. And participate in independent assessment for technical performance that helps in the proficiency testing. And for the traceability and the measurement uncertainty, we have to ensure our comparability of measurements is easy if we are doing the same experiment in some other labs. So your repeatability of your experiment or the reproducibility of your data is very important. So we must follow our well-defined quality controls and quality assurance practices during the measurement of these different data related to our common problems. So at the end, I'm looking forward for your nice comments and suggestions, and that how easy to understand that how we can relate our experimental measurements that are related to chemistry or analytical data interpretation that are actually helping us to solve different real world problems. Thank you.